In this equation, when we are solving for the wavelength of the soap, we use the thickness of the bubble in D, the index of refraction for N, and for M, we use the constructive interference factor. The equation we will be using is lambda equals 2 times N times D over M plus 1/2. We use this equation to find the wavelength of the soap, or the wavelength that passes through the soap. So we multiply 2 by 1.40 because that's the N value, 3 times 10 to the negative 9 because that is the thickness in nanometers, and divide that by 1 plus 1/2. In this we get 5.6 times 10 to the negative 9th meters. We can only see the visible light between 400 nanometers and 700 nanometers. So, and 1 is the only value that we have a constructive interference, and that value is the 560 nanometers that we found.
In part B, we had to find the two smallest possible values of N2, first assuming that N2 is less than N3. To do so, we used the same formula used in part A, which was the wavelength equal to 2ND divided by M plus 1/2. We set the wavelength equal to 650 nanometers of light and M equal to 0. Then we proceeded to solve for N. The final product was N equals to 1.2.
We set the wavelength equal to 2ND divided by M plus 1/2. We plugged in the 650 nanometer of light for the wavelength and set that equal to 2 times N, because we're solving for N, times 270 nanometers, which is the thickness, and divided that by 1 plus 1/2 using M equals 1. For that, we got N equals 1.81, which is a possible value of N that is greater than N3.